In January 2026, NASA's TESS satellite caught something extraordinary. As it reobserved 3I Atlas, an interstellar object already known for defying expectations, the satellite captured data that suggests this is no ordinary comet. The findings are as puzzling as they are unsettling, an object moving in ways we don't fully understand, emitting jets and dust with precision that feels deliberate. The more we learn, the more it seems 3I Atlas wasn't just passing through. Avi Loeb, one of the leading researchers, has raised the possibility that we're not looking at a natural object at all, but something far more engineered. Could the findings from TESS prove him right? NASA's Transiting Exoplanet Survey Satellite, TESS, has made an important re-observation of 3I Atlas, the interstellar object that passed through our solar system in 2025. TESS's recent findings, which span the observation period from January 15 to January 22, 2026, have revealed critical details that have sparked fresh speculation. As 3I Atlas continues its passage, it shows behaviors that are far from typical for a comet. Most notably, the object has brightened significantly, displaying a noticeable amplified opposition surge, a phenomenon where light reflecting off an object and its surrounding dust is intensified, revealing new features. This brightening effect suggests that 3I Atlas may possess properties that aren't usually seen in typical comets, as its surface and surrounding dust seem to respond differently to sunlight. TESS also confirmed that 3I Atlas is continuing to follow a retrograde trajectory, meaning it is moving against the general direction of the solar system's planets. This rare characteristic points to the possibility that its movement is not purely accidental, but could instead be guided by an external force. The object's precise motion and trajectory suggest something more intentional, which only adds to the intrigue surrounding its origins. TESS's detailed imaging also helped scientists track the object's brightening rate, offering unprecedented insights into its composition. This behavior, combined with the amplified opposition surge, points to an object that is far more complex than a typical comet. With TESS's findings now in mind, Avi Loeb, one of the leading researchers on the phenomenon, has proposed a groundbreaking theory that 3I Atlas might not be a natural comet at all, but instead something engineered, possibly by an extraterrestrial civilization. Loeb's perspective is grounded in a series of anomalies, each one of which challenges conventional explanations for comets and interstellar objects. One of the most striking anomalies is 3I Atlas's trajectory, which has been observed to move in a retrograde direction. Retrograde motion, where an object moves in the opposite direction of the planet's orbits, is exceedingly rare, and the probability of its occurrence by chance is only 0.2%. This unusual movement stands out even more when we consider the timing and positioning of the object. 3I Atlas passed close to Mars and Jupiter at highly precise distances, 29 million kilometers from Mars and 54 million kilometers from Jupiter, at a time when its perihelion, or closest approach to the Sun, was invisible from Earth. Ordinarily, comets are brightest at perihelion, but 3I Atlas managed to remain hidden during this crucial moment. This perfect alignment suggests that the comet's path is not purely a result of gravitational influences, but rather a finely tuned event, orchestrated in some way. Furthermore, the upcoming encounter with Jupiter on March 16, 2026, adds yet another layer of mystery. At this point, 3I Atlas will pass within 53.6 million kilometers of Jupiter, a distance that precisely mirrors the Hill radius of Jupiter, which is 53.5 million kilometers. The Hill radius is the region around a planet where its gravitational influence dominates over the Sun's, making it an ideal location for spacecraft to remain in stable orbits with minimal fuel use. Loeb posits that this precise alignment could indicate that 3I Atlas is positioning itself to deploy devices at Jupiter's Lagrange points, the gravitational sweet spots where objects can remain with minimal effort. If this theory holds true, it would suggest that 3I Atlas is not a comet at all, but rather a technological artifact with a specific mission, perhaps even an interstellar probe or satellite. Adding weight to Loeb's hypothesis is the remarkable observation of the anti-tail of 3I Atlas, A comet's tail typically points away from the sun as a result of the solar wind pushing dust and gas outward. However, 3I Atlas exhibits a highly unusual anti-tail, a stream of material extending directly towards the sun, which creates a sharp, focused jet of particles. This is not the typical cometary tail, which tends to diffuse and scatter light. Instead, 3I Atlas's anti-tail is collimated, meaning the material is ejected in a highly organized and narrow beam. The exact alignment and precision of this jet seem deliberate, suggesting that the object may be utilizing directed energy or propulsion. Loeb theorizes that this anti-tail could be part of a technological feature, possibly engineered to protect 3I Atlas from solar winds or to serve as a communication signal, either to us or to another destination.
The composition of the object's outgassing further deepens the mystery. Normally, comets release gases like water vapor, carbon dioxide, and other simple molecules. However, 3I Atlas's gas plume contains a significant amount of nickel, a metal not typically found in cometary atmospheres. What is even more remarkable is the nickel-to-cyanide ratio, which is far higher than anything observed in other known comets, including 2I Borisov, a comet of similar origin. This unusual composition suggests that 3I Atlas is made of something other than the typical icy mixture of dust and gas. Instead, it could be composed of synthetic alloys, materials that are characteristic of artificial objects rather than naturally occurring ones. Loeb's theory gains strength here, as he argues that this could be evidence of intentional design behind the object's composition. Furthermore, the dust particles surrounding 3I Atlas are significantly larger than those found in typical comets. Comets usually emit sub-micron-sized particles, but the dust surrounding this object contains particles large enough to resist the pressure of the solar wind and radiation, a remarkable feat for any natural comet. Smaller particles would typically be scattered by the solar wind, but these larger particles seem to withstand these forces and remain intact as they travel through space. This anomaly suggests that the dust cloud might not be the result of normal cometary outgassing, but rather an engineered dust veil that could serve a specific purpose, such as shielding the object from the solar environment or enhancing its reflectivity to be observed from afar. In addition to these already perplexing anomalies, one of the most striking features of 3I Atlas is its extreme negative polarization, a property that typically points to man-made objects but is rarely seen in natural celestial bodies, especially comets. Polarization refers to the way light waves are oriented as they pass through or reflect off an object. Normally, light traveling through space interacts with materials in ways that result in random polarization, where the light waves vibrate in all directions. However, when light interacts with certain surfaces, particularly those that are engineered or uniquely structured, it can become polarized in a specific direction. This highly controlled behavior in the light waves suggests a surface with properties that are far from random or natural. What makes 3I Atlas's polarization particularly intriguing is its extreme negative polarization. In simple terms, negative polarization means that the object is reflecting light in a way that defies the typical behavior of natural surfaces. The polarization observed in 3I Atlas is far stronger than anything seen in any known comet. To put this in perspective, comets typically exhibit a low to moderate degree of polarization due to the scattering of sunlight by their icy surfaces. But 3I Atlas displays a degree of polarization that exceeds all known cometary behavior. This stark difference raises the question, why does 3I Atlas behave so differently from anything we've observed? The surface properties of 3I Atlas could be the key to this anomaly. One possibility, suggested by Loeb, is that the object's surface is not natural but engineered, with a highly specialized structure that interacts with light in ways natural materials cannot. The surface might be designed to reflect light in a way that makes the object stand out in specific wavelengths, perhaps even to manipulate light for purposes that go beyond mere reflection, such as concealing its true nature or deliberately signaling other objects.
This engineered surface could be designed for stealth purposes, perhaps to make the object less detectable by traditional astronomical observations, or it could be serving as a beacon, intentionally designed to attract attention from other distant objects, or even extraterrestrial observers. The idea that a comet could have such a purpose-built surface is radical, but it becomes increasingly plausible when you consider the degree of precision and control observed in 3I Atlas's polarization. Moreover, 3I Atlas's rapid brightening and its distinct blue hue as it approached the Sun further distinguish it from typical comets. In most cases, as a comet gets closer to the Sun, its icy surface begins to vaporize, releasing gas and dust and producing a gradual brightening over time. As this happens, the comet usually takes on a redder hue due to the heating of its surface and the emission of certain wavelengths of light. However, 3I Atlas defies this pattern completely. Its brightening was unusually fast, and the comet's blue color, instead of the expected reddish tint, suggests that the object's surface is not composed of the usual icy or dusty material found in most comets. This blue hue is far from typical. A blue-colored comet would typically imply the presence of reflective materials on its surface, materials that can scatter shorter wavelengths of light, like blue and ultraviolet radiation, more effectively than the common reddish materials seen in most comets. Instead of the expected dull, reddish appearance as the object heats up, 3I Atlas appears to be reflecting sunlight in a distinctive blue spectrum, suggesting that its surface composition is unlike any natural comet observed before. The sudden increase in brightness and the blue coloration could be due to reflective, engineered coatings or other specialized surface treatments designed to interact with sunlight in very specific ways.
Loeb has speculated that this unusual behavior, the rapid brightening, the blue color, and the polarized light, could all point to 3I Atlas being an alien artifact rather than just a natural comet. These features, especially when considered together, could be indicative of a purpose-built surface. In other words, 3I Atlas could have been crafted to perform certain functions, potentially even designed to appear unlike any object we've ever encountered. Whether it's through reflective coatings that help it shine in unusual ways, light manipulation to obscure its true nature, or some other form of signal that it is sending to the universe, the engineering behind 3I Atlas's characteristics is becoming increasingly hard to ignore. 3I Atlas's rapid brightening, unique blue hue, and extreme polarization are not just quirks, they are anomalies that cannot be easily explained by natural processes. They suggest that the object might be far more than a stray comet traveling through our solar system. These properties seem purposefully designed to either hide its true nature or broadcast its existence to the stars. The engineering of its surface and the deliberate manipulation of light may indicate that 3I Atlas is not simply a cosmic visitor, but possibly a deliberate message or technological relic that has traveled from beyond our solar system. These possibilities raise profound questions about what 3I Atlas really is and whether its creators intended us to notice these anomalies at all. Finally, SPHEX, the space observatory designed to study the universe in infrared, provided another perplexing clue. Initially, SPHEX detected icy fragments around 3I Atlas before it passed perihelion, but these icy signatures disappeared after perihelion. In their place, the object began releasing organic molecules such as methanol, formaldehyde, methane, and ethane. These complex organic molecules are far more complex than the simple ice that typically characterizes comets. The fact that these organic compounds appeared after perihelion suggests that 3I Atlas underwent some form of protection or shielding during its long interstellar journey. It raises the possibility that this object was designed to survive extreme conditions during its passage through the cosmos, perhaps by a protective outer layer that kept it safe from the harsh radiation of deep space. All of these anomalies, taken together, point to something far more extraordinary than a typical comet. The precision of 3I Atlas's movement, the unusual composition of its gas, the engineered properties of its dust, and the deliberate behavior observed in its anti-tail all support the theory that 3I Atlas is not a natural object. Instead, it might be the first evidence we have of an artificial probe or technological relic, a potential artifact from another civilization, or even a deliberate message from a distant world.
As more data comes in, the mystery of 3I Atlas continues to unfold, leaving scientists with one critical question. Is this interstellar object simply a remarkable natural wonder, or could it be something far more profound, carrying a message or technology that challenges everything we know about the universe?